On this 2.7 EcoBoost F150, P0315 is about the crankshaft pulse wheel profile. In plain language, the PCM may not have the crankshaft pulse wheel tooth spacing learned, and that can take the misfire monitor out of play. The truck may run normally with a stored code, or if the crank signal itself is missing or unstable, it may crank with no start or show RPM issues during cranking. Broadly, think about the learned profile, the crankshaft position signal, the pulse wheel condition, wiring and connector integrity, and the PCM side of the circuit. Start with the basic system checks, and if other codes are present, understand what they mean first, instead of treating every crank-related code the same way. For this code, the first useful split is whether the PCM sees a believable crankshaft position signal while the engine is cranking. Make sure the battery is fully charged and the starting system is working correctly. Remove the fuel pump fuse to disable fuel delivery. Turn the ignition on, monitor the RPM PID at the PCM, and crank the engine. Normal cranking speed is between 150 RPM and 350 RPM, and the engine should crank for greater than 3 seconds while attempting to start. If RPM is greater than 150 RPM, the target P0315 path is straightforward. Carry out the misfire monitor neutral profile correction with the scan tool. Clear the PCM DTCs and repeat the self-test. If the engine cranks less than 3 seconds with no RPM signal, do not chase the profile relearn yet. Verify the mechanical timing path. Make sure the camshaft sensor trigger wheels are not damaged, and confirm the camshafts are rotating while cranking. Repair what is found. Clear the PCM DTCs, and repeat the self-test. For the other no RPM situations, continue into the crankshaft position sensor and trigger wheel checks. With the ignition off, inspect the crankshaft position sensor area and the trigger wheel. Look for contamination, debris, obvious physical damage, and a trigger wheel that is bent more than 1.0 millimeters. A damaged wheel or contamination on the magnetic surfaces can create an intermittent CKP signal. If you find a concern, repair it as necessary. Reset keep alive memory, then carry out the misfire monitor neutral profile correction with the scan tool. If no concern is present, continue with the circuit checks for this engine. There is also a CKP bias and circuit block that needs to be handled in order when your diagnostic path puts you there. If the path into this block is not clear, pause, recheck the earlier diagnostic path, and avoid guessing. Also, make sure you have the exact connector and terminal callouts before putting meter leads on the circuit. First, disconnect the CKP sensor connector. Turn the ignition on and check for correct CKP bias voltage at the PCM side. The voltage should be between 1 volt and 3 volt. If that check passes, turn the ignition off and check CKP sensor resistance. The resistance should be between 250 ohms and 1100 ohms. If sensor resistance is out of range, install a new crankshaft position sensor, reset keep alive memory, and carry out the misfire monitor neutral profile correction with the scan tool. Next, with the ignition off and the PCM connector disconnected, check the CKP harness shield ground between the shield and the harness and the PCM connector terminal. That resistance should be less than 5 ohms. The shield is there to protect the CKP signal from outside electrical noise, and it is grounded internally through the PCM. After that, check for a short between CKP positive and CKP negative. Resistance should be greater than 10,000 ohms. Then check the CKP circuits for an open. Resistance should be less than 5 ohms. Then check the CKP circuits for a short to ground. Resistance should be greater than 10,000 ohms. Finally, with the ignition on, check the CKP circuit for a short to voltage. If any voltage is present where it should not be, repair the short circuit, clear the PCM DTCs, and repeat the self-test. Next, check voltage at the sensor. With the ignition off, disconnect the CKP sensor connector, then turn the ignition on. On the 2.7-liter EcoBoost, measure between C1220 pin 3 and C1120 pin 1. You are looking for 4.5 volts to 5.5 volts. If that feed is not there, move into the supply circuit diagnostic path before continuing. Do not treat that as a finished CKP sensor check. If the feed is present, turn the ignition off. Disconnect the PCM connector and check the open circuit path from C1120 pin 2 to C1232E pin 98. That resistance should be less than 5 ohms. If it is not, repair the open circuit, clear the PCM DTCs, and repeat the self-test. If it passes, check for a short between circuits from C1120 pin 2 to C1120 pin 1 and C1120 pin 3. That resistance should be greater than 10,000 ohms. If it is not, repair the short circuit, clear the PCM DTCs, and repeat the self-test. Then check for a short to voltage at C1120 pin 2 with the ignition on. If any voltage is present, repair the short circuit, clear the PCM DTCs, and repeat the self-test. If the complete meter hookup for that short to voltage check is not clearly identified in your connector information, pause and verify the circuit identification before continuing. Do not guess at the lead location. If the circuit tests pass, look for an intermittent fault. With the ignition off and the PCM connector connected, visually inspect the CKP and CMP wiring for chafing or other physical harness damage. Chafed wiring or harness damage can create an intermittent short in these circuits. If you find a concern, repair it as necessary, clear the PCM DTCs, and repeat the self-test. If you do not find anything there, turn the ignition off, disconnect the PCM connector and the CKP sensor connector, and inspect for pushed-out pins and corrosion. Reconnect the PCM connectors and the CKP sensor connector. Make sure everything is seated correctly, and verify whether the concern is still present. If it is still present, and this is not a cranks no start case, install a new crankshaft position sensor, reset keep alive memory, and carry out the misfire monitor neutral profile correction with the scan tool. If the concern is gone, the system is operating correctly at this time, and the issue may have been caused by a loose or corroded connector. Keep verification separate from testing. After any repair, profile correction, or connector correction, clear the PCM DTCs and repeat the self-test. For P0315, do not call it fixed just because the engine starts. Confirm the relearn has been completed where required, confirm the code stays gone, and confirm the original concern is not present. Takeaway: prove the PCM has a stable crank signal first, then perform the neutral profile correction when the signal is valid. For more diagnostic training, visit stepdiagnostics.com.